You've encountered this situation before when you're surfing the net and just all of a sudden everything just slows down to a grinding halt. For some reason, that one page, that one picture just won't load, even though you're on full signal and everything just seems to be good. Or when you're playing a video game, you're going to engage an enemy, you're about to go in for the kill, and then suddenly you just can't move. You get this giant lag spike, and it disables everything you want to do. And these lag spikes happen because of the way the internet is built up. Unfortunately, when the internet was built, it was a very haphazard project with a bunch of cables, and we're kind of living with these consequences today. Now, today we're going to have an interview with the CEO of Noia, Dom Pavlauskas, and what they're trying to propose is to fix a lot of the problems with the internet to drastically improve both reliability and speed on the network as well. We talk about using blockchain technology to give almost a map of the entire internet so we can route data efficiently and avoid traffic jams. It's almost as if sometimes right now data gets funneled through one way and it gets massively jammed into a pile-up and data can't move across. And we talk about ways to solve this.
So hi guys, and thanks for having me here. So what fascinates me is the internet itself. Basically, internet is just loads of cables that run across the world, just cables. When internet service provider provides a internet connection to a home user, it provides a cable. Everything goes through cables, and those ISPs right now, internet service providers, they are connected with each other. And this is how the internet is built.
Okay, so the internet is just a bunch of webs. I mean, I guess that's where the name the web came from. It's just a web of cables haphazardly built together. So what are the problems with doing this? I mean, people have been using the internet for some time. You know, we surfed YouTube and Amazon. What's there to improve here?
So basically, imagine that this network of networks is built of like different thousand of different pieces. And right now, those different pieces it determine the fragmentation of the internet. And this fragmentation and the nature of how the internet was created determine the protocol, the routing protocol design. Current internet routing protocol used on the public internet is Border Gateway Protocol. So that protocol was created in 1994, and this protocol is enabled any computer to find another computer. But this protocol has a lot of design limitations, and companies like Google, Amazon, Microsoft started to release a lot of papers discussing like the Border Gateway Protocol isn't working, isn't delivering internet traffic efficiently, and it costs like huge money for enterprises worldwide. And there's a huge difference. Right now, you can't program how the internet is being routed. So, ISPs are using Border Gateway Protocol, and Border Gateway Protocol always chooses the shortest path to the destination, the shortest path. And imagine when everybody chooses the shortest path every time, like these shortest paths, become congested.
Right.
And this is where the inefficiency, happens. So you need to, in order for the internet to become smart, that's why we call it programmable, where you can program the routes. You can do everything you want with every single packet on the internet. So Noia is focusing on segment routing, but what segment routing basically does, it enables routers to understand what's written in every single data packet. Okay.
Right.
So we enable the transition from the current internet infrastructure, which is based on thousands of different networks, into a infrastructure which is based on programming the data itself, the packets, and then sending it across the internet, and routers understand what to do with those packets. Because of the Border Gateway Protocol, almost like 40% of all internet traffic is being routed like inefficiently. And this inefficiency brings performance loss, which at the end is felt by the user, by a regular user like you and me. So the wrong protocol right now creates a lot of problems with routing,
right,
which also creates a lot of problems with security, because for example, IP hijacks right now are the most popular hacking attack strategy.
So it's like basically if you consider the internet like the highway, sometimes there's congestion, and right now it's haphazardly arranged. The way that you can redirect traffic and can go through various ports, maybe say a communication from me to the United States right now, from Hong Kong to United States, it might route through Japan, then it might pass through Taiwan, then it might pass through Korea. That's an inefficient routing. It takes longer. And right now there's no top-down approach to the internet where it guides this traffic. It's just kind of purely based on just where it wants to go right now. So what you're trying to add is adding another layer to help improve the efficiency of the transportation and also build a kind of a network for that.
Yeah. So imagine we have these thousands of different networks. Yeah.
Mm-hmm.
And what we want to do, we want to unify them into one programmable network. Yeah. Mm-hmm. In order to unify them, you need to make them speak the same language. Yeah, make the infrastructure understand the same protocol first. So this is why we utilized segment routing protocol. And right now, the adoption of segment routing is increasing. We can make that infrastructure to understand one protocol. Yeah, once it understands one protocol, you can take a blockchain technology, which provides a database, like a distributed database, to store all the connections on the internet into one database. And once you have database, and once you have a network which understands the same language, the same protocol, then you can start programming and as you said, have this top-down approach where you can reinvent everything from the core.
Right. So it's almost like giving every piece of hardware a map. So like they have like almost a map of how everyone is the internet is currently configured, and that map updates. It's almost it's kind of using blockchain technology instead of synchronizing people's accounts, it's synchronizing this general map. What would this bring though? Like how much faster will this make our internet? Like if people really do adopt the system, like what are the tangible benefits of it?
Right now, our tests shows that sometimes internet can become like 15 times faster, 15 times. So
wow.
That's a huge difference. And but I think the most importantly, what this product can do is solve some basic daily problems with the internet for a regular user, because of course there are people like gamers or people like who watch a lot of live videos online. Those guys, they feel the most, because they need the internet connection as good as possible, and because they know how it feels when the internet is broken.
Okay, so we have this problem of the internet being slow, being inconsistent. Now you're proposing a solution, but I bet a lot of other companies are also proposing solutions. You talked about Google before, Apple. Why would providers choose Noia over some bigger companies, and why does this work better?
I think it works better because it solves a fundamental problem of internet anonymity and like autonomous internet. Internet should be decentralized, and it is decentralized in its nature. And companies like Google right now, they're building their private internet basically. They're connecting their data centers with cables, and if you have Google Fiber at your home, and you use YouTube, probably it is a chance that you're using only Google's private internet without even going on a public internet. So that creates a lot of questions about like privacy, about security, about a lot of questions.
Centralization, because they can cherry pick what internets to show you. Like if you want to build a YouTube competitor, well, good luck, because people aren't going to use it. LOL, right? Google's just going to laugh, ha ha ha.
So that's the key problem. So the only way to solve current internet problems is to build overlay networks, like build other networks like on top of internet itself. So Google is doing that, and of course, if for example one day Google would own the internet, would have the biggest overlay network, then of course Google will have its private internet, and of course the routing would be better. Maybe everything would look better, but the thing is that the privacy and your data on internet would become in danger. you know. So nobody wants privatized internet. Nobody wants those things. So the blockchain and this programmable internet architecture, where you enable every single piece of hardware to become open and like act as a transit point to become shareable, where you make this whole structure act as a one. It's the only way how you can create the maximum utilization and also avoid centralization of resources like what is happening right now.
Okay, so we're talking about all this. What's the current stage of adoption? So who's on board? What's happening? And how's it running?
So currently we've been running our testnet for about a year right now, and we have more than 5,000 nodes globally. So community downloaded nodes, and they help us to set up nodes in every different locations across the world. We have nodes from Hawaii, to whatever, somewhere in the middle of Russia or whatever. So
Right.
so people helped us to build this map, to build the network, and then we started working with data center companies, with big data center companies like eShelter. It's one of the biggest data center company in Europe. I think it's probably the biggest. And we entered Microsoft partnership program recently. So that also added a lot. So we collected data center partners and cloud providers into one category, and then we also combined their infrastructure together with community infrastructure. So and this is how we got this first version of programmable internet. So we see that we already provide a good service for our users. And first of all, these users are websites who started using Noia Cash. When we released Noia Cash alpha version, a lot of websites registered and started integrating the networking to their websites. That's the first thing. The second thing is the enterprises. So right now we have around 10 big like companies testing and using the network. Internet advertisement exchange, data center, few data center companies, few gaming companies as well. So this information is some of this information is announced on our website. Some of this information is still kept private, and we will announce that fairly soon.
Right. Okay. So you talked. Okay, let's back up a little bit. You talked about websites using this and something called Noia Cash. Can you tell me what Noia Cash is?
So Noia Cash is a distributed peer-to-peer content delivery network. Yeah, it's one of the applications of the programmable internet. So the person right now can share his internet bandwidth, and it's some fair some storage space on his computer, and then he connects to the network, and network then caches some content, some website content in his computer, and his computer becomes a node which can deliver the content. Yeah. So if someone and if a website owner installs Noia Cache, then his website, it becomes available in every location around the world.
So it's a peer-to-peer cache, right? Because we deliver. There's a lot of content delivery networks out there, but why choose peer-to-peer? Why would people use something that's kind of almost by volunteering a bandwidth rather than say a professional data server in Google?
Because sometimes it's very hard to reach the customers. If you're a website owner and if you want your website to operate globally, if you want your people to connect to your website and from any location around the world, you'll face a lot of difficulties. So that's why sometimes people use content delivery networks, like Google Content Delivery Network or Amazon's, but they feel that the performance of those networks are not satisfying, and some of the locations are not reachable anyway, because Google has limited infrastructure. Amazon has also limited infrastructure. What peer-to-peer delivery does, it basically it gives an ability to install cache cache device, cache storage in any place around the world. People can run a node, everywhere. Everywhere. As I said, we have a node in Hawaii. I think Google, Amazon, nobody has a node in Hawaii. Okay, so that, we can deliver data to Hawaii much more better than Google can. So.
Right. So it's all about so for bigger companies and bigger services and CDNs to do it, they need to actually build data centers. But here, anyone can build it. Anyone can be joining the network. It's permissionless, and then it increases that speed of adoption, basically, to go around the world. I see.
And also, I want to add, because I think our the nearest plan we have is to release an application which would enable users to not only share their bandwidth, but also to use the programmable internet to get the best connection possible, and then people would understand what's the difference, because that application would only take better route if your current route is not sufficient. Okay, right. So it will analyze your every single packet coming from your computer and make it sure that these packets reach the destination at best possible way. So this is our near-term goal.
Cool. Okay, so we have all these goals. We have trying to get Noia Cash to improve the speed of internet. What's that? Now you also have a token as well. So can you tell me what's happening with your token? What's it for?
So token will act as two things. One is a transaction fee for the ledger transactions, and the second a medium of exchange. Yeah. So we call it a digital currency because it is a native asset built in the Noia system. And first of all, for a regular user, for example, the first utility we have is once you download the application, then you can start earning those tokens for sharing your bandwidth, but you also spend those tokens for using the programmable internet. Okay, so programmable internet basically balances the token economy between the users, which support the network by providing the bandwidth and also pay for its services. So basically, if you want to get a better user connection, maybe someone else running a node, and as you said, you wanted to connect to a server in the US, so you want to use someone else network, to connect to that server. Yeah. So you're going to pay Noia token, for that service. And maybe someone else would love to connect through your computer in Hong Kong, so this is how the tokenomics work. And also is a transaction fee, because every transaction on the ledger has a minor fee associated with it. So this fee goes to validators for validating the transactions. And this is the second use case. So basically every person who likes to use the programmable internet, or likes to engage, or is it a company or is it a person, doesn't matter. It has to have a Noia token, digital currency transaction fee.
Right. So it's a native token. It's used to reward anyone who joins the network and participates, or it's used as a token for currency for usage. So you're doing the token launch soon as well. So can you tell me a little bit about that?
So we did a small launchpad sale in Korea last week, and it went well, because we have a pretty solid community in Korea for many reasons. We believe that this country is really fastly moving forward with the internet technologies. Mm-hmm. And so we had the sales, small sale in Korea, and then right now we have the upcoming listing on KuCoin Exchange on the 22nd of July.
Cool.
So yeah. So basically, we also launched a program we call Foundational Members Program, where we reward the token community holders. So we encourage people to buy tokens and then to hold them for the upcoming 5 months, and they will get rewards based on the amount of tokens they bought. So yeah, that program is pretty interesting because community were asking about where's the IEO and why not IEO. But I think we as a team discussed this topic a lot, and we decided that it's the best way to go forward and provide access for every community member to participate, because IEOs are usually right now very speculative. It creates a lot of hurdles to get something out of it. Yeah.
Okay. So you're doing a direct to an exchange, and you also have a program for the community as well. How would
Yeah.
people find out more about it? So what website do they go on?
Yeah. So just Noia.network, you'll find every information there. And you can also go to Medium,
Okay.
medium.com/Noia network.
And recently you also have a new member joining your team as well. Can you tell me a little bit about
Yeah.
how that's progressing?
Yeah, so that's very interesting because not recently, we've been working for quite a while together, but recently we made it publicly. So Bill Norton, a co-founder of Equinix, the largest data center operator in the world, right now worth $400 billion, joined our team. So Bill Norton joined also as a co-founder because he helped us co-found the concept of programmable internet. We've been working for a while together, creating this concept, and his experience, because Bill been working in the internet industry all his life. So he knows, starting as a co-founder of the largest data center company in the world, which is also like a huge achievement. Ending, working with companies like NVIDIA, LinkedIn, Hollywood film producers, that kind of stuff. So that is, Bill joining proves us as a team, because we've been working so hard these past like few years. And right now we're getting addition, which can really be game changing stuff.
Awesome. So I really hope that moves forward, and tell me how it goes. And I'll try to install a node sometime too. And hopefully we can talk about some nodes and do some mining on the Noia network. So thank you so much for coming today. I hope everyone can discover more about Noia and also about the policies and how it can drastically improve internet as well. So thank you so much for this interview.
Thank you. Thank you, guys. Thanks.